our polar coordinates. More of it, our third installment. We're going to now take our polar r comma theta, and we'll change it into x's and y's. We'll get x's and y's, we'll change that shit into polar. We'll be able to go back and forth between our circular coordinate system and our rectangular coordinate system. Circular being polar, rectangular being x's and y's. X's and y's can also be called the Cartesian, x's and y's. Let's go. So let's look at a graph. So we're gonna build this ourselves. We go through and let's just draw something into the first quadrant, make it mellow and make a point. And we say this point is r comma theta, which would mean that this length here is r, and that there's some angle theta. Now our game is we want to go find out. We're like, well, dude, I want to know what my x and my y point is, but I want to get my x's and y's all in terms of r's and thetas. So we're going to want to be like, what does x equal in terms of r's and thetas, and what does y equal in terms of r's and thetas? I'm going to get rid of this. This is what we're going to go. And now, you know what? You know that we can create a right triangle here? If we just drop ourselves a little perpendicular. Boom! And isn't this going to be this length here? Let's think about it in x's and y's. Isn't this x? And wouldn't this height right here be y? So now everything's all tied together. Well, shit. It looks like we got three sides of a frickin' right triangle, and we have the angle. I mean, we can go back and forth quite a bit here. If I just gave you numbers, this shit should be just simple on block. So let's see if we can't go solve for x. And we're thinking that we're given these two pieces of information. So we want to use these three pieces of information, not the y. So we're like, all right, from this angle, we have the adjacent, and we have the hypotenuse. Oh, I mean the radius, right? So that's cosine. So we could say that cosine of theta is equal to that x value over the radius. Well, if you just multiply the r over to the other side, you're going to find out that x is equal to r cosine of theta. So let's get that shit written out there. Boom. This is something you want to get locked into your head. If you take nothing else away from polar, x is equal to r cosine of theta, y is equal to, I wonder what that one could be. How about sine of theta is equal to the opposite, your y, over the radius. You move it over and you're going to find out that y is equal to r sine of theta. Again, if you take nothing from this section except this, your teacher won't be super pissed off. Now, granted, you're going to have to do much more of that onto your tests and worksheets and stuff, but that's what I'm hoping you remember after this. You're like, that x's go with cosine, y's go with sine. X equals r cosine of theta, y equals r sine of theta. It shouldn't be something new that x's go with cosine and y's go with sine. About 2 months I've been telling you that. But I only expect you to retain maybe about 2% of what I say anyway. All right, well, now we can go the other direction as well. Or it's like, do you think that we could write the radius in terms of x's and y's? And then we want to see the tough one is the angle. If we can get the angle in terms of x's and y's. So I'm going to lose this stuff down here. So there we go. Let's go look at our radius. And oh, by the way, it's the same shit. We're talking about the magnitude right now. I mean the hypotenuse. It's all the same shit. So we look and like, we already know. Isn't x squared plus y squared, a squared plus b squared equal to c squared? And now let's hit that thing with the square root, and we can say that r is equal to the square root of x squared plus y squared. And yeah, we can have a negative radius now. That could be a plus or a minus, but we're going to leave it up to you. Do you want to use the negative radius, or do you want to use the positive radius? Exactly. So we're going to call this thing the square root of x squared plus y squared. I'm going to write below it, because this gets used a lot later, and just the r squared is equal to x squared plus y squared. Just writing that stuff. So there's how we can convert for our radius. Now the angle is the tricky one, so let's go see what happens there. Now in our game, we just want to think about it just in terms of x's and y's. We don't want to use this r, so this r is off limits. We just need to find something where we can tie this angle, theta, with our x and our y. But if you look at the angle, it's basically saying from this angle, you have the opposite and the adjacent. So we could say the tangent of theta is equal to y over x. The slope of that line looks like it's y over x too, huh? Neat. Well, this is true. Now you got to know what quadrant it is, but this is the same game you had to play from vectors. That your theta is going to equal inverse tangent of y over x in quad 1 and 4. But theta is going to equal inverse tangent of y over x plus pi in quad 2 and 3. Oops. Man, I Roman numeraled it the whole way till the end. Boom! 2 and 3. So here it is. Here are our formulas. Now this is the way I write it down. In purple, down below, this is how I have it. Now this is what your textbook says for your conversions. It's merely this. That x is equal to r cosine of theta, y is equal to r sine of theta. Same thing I told you. R squared is equal to x squared plus y squared, but I took it a step further. But right in here, tangent of theta is equal to y over x. That is true. That's true for all. I'm writing down all the conditions because you have to go solve for that dang angle. You have to go get it. And it's going to matter as to where you set it up because inverse tangent does not understand angles that are larger than 90. It doesn't understand quadrant 2 and quadrant 3. We have to force things into quadrant 2 and quadrant 3, just like we learned from vectors. So I'm going to shut up about that because you already know. And the next one, we'll start doing a couple conversions, getting some practice.